Hello, Mr. Eric, Mr. Ryan, are you right? Yeah? We talk about island thingy, remember? Island. We use the depth search to count the number of islands, right? And we use the depth search to count to return the maximum size of the island, right? These two are similar. We use this depth search. Today we're going to solve another island problem. Is given a two-dimensional, yeah, two-dimensional metric. One is island, a land. 0 is what?
Water.
Water, yeah, you see. Okay, so if I do this 1 1 0 0, okay, then 1 1 1 1 1 1, and then 1 0.
That's such a big matrix.
Okay, I'm just going to do something. Okay, I just
Hey.
yeah. Don't worry. I just randomly to filling this metric. You know.
It's not really. Hey, it's uneven.
What are you?
At the bottom, they're like 1, 2, 3, 4,
Okay,
5.
too many. Yeah. Okay. Okay, so this 1 is the land, 0 is water. And how many lands are there?
They're like so many. They're 1, 2, 3, 3, 7, 4,
No.
7 by 7,
Okay,
45.
Okay, so I'm going to use this color. Okay.
Wait, so.
No, wait. Yeah.
They're like a million islands.
No, just this. Look at this. Why is the million? You can count. How many? Actually here. Yeah.
You didn't recognize that.
Okay. Yeah?
Yeah.
So how many is it? 1, 2,
Six.
3, 4, 5, 6.
6.
Okay, so we want to know the surrounding island. Okay, what's surrounded?
Surrounded.
Surrounded island means that the island needs to completely be surrounded by zeros. Okay, it needs to be surrounded by zeros. So which ones are completely surrounded by zeros?
The first one, the 2 one.
Why is this? No. This no. Which one?
No. 1, 2, 3.
This one, right? So completely surrounded by zeros,
It's
right?
not.
Why is not?
There isn't the one here and
No.
one
That's
there.
fine. It's not horizontal, but look, it's completely. We only consider the horizontal like that.
Yeah, but it isn't here.
That's fine.
And it isn't here.
Look, this one is completely surrounded. Okay, we only considering the horizontal and vertical. We don't consider this diagonal. Okay, so only this one.
I'll do it around.
Okay, just listen to me.
Then,
Yeah, I'm talking about this one and this one, but not this one, yeah, because there's no water here, and there's no water here. Okay, so in this case, return 2. Yeah, makes sense.
It's like,
If it's on the border.
Yeah,
If it's on the border, it's not the island we're looking for, because if it's on the border, there's something here. That you can imagine this is not surrounded.
houses.
Sorry?
I'll draw houses.
Okay, houses. Yeah, maybe houses.
I'll draw all of them.
Okay. Got it? Yeah. Houses. All the football pitch. Okay. All the trees. Yeah, forests. Yeah. Got it. So you don't know what's beyond this. Beyond this. Okay. Any idea how we're solving this? Any idea? What's this? Any idea? Come on. That's it. Okay, that's it. Any idea how we solving this?
Well, we don't look at the islands on the water.
Yeah, that's good. We don't look at the islands on the border, yeah? So how do we do this? Remember, before, we want to count the depth of search, right? We want to count the number of islands, including the border, right? So how do we do it? We just go through each one. If it's 1, we do the depth of search and we plus 1, right?
Okay.
Yeah? So,
you
what?
delete all of the out eyes. Just kidding.
Kind of similar. How about if we first? How about
You cut this island.
Yeah. How about if I do the depth of search starting from the border, if it's an island, right? And then mark this as 0, and then we can do this depth of search the second time. Yeah, does it work?
But how about this island?
Yeah. Look, what I'm going to do is I'm going to start with the border. Look, border, yeah. If it's 1, I do the depth first search and I mark it as 0. Right? Here, I mark it as 0. Here, I start here, I mark it all 0.
Oh.
And here, I mark it all 0. Okay, so what's next?
All of the ones.
Right.
They're all
And then-
round there.
Delete all of the zeros.
And then we just go through these ones, yeah?
And count
Easy.
the
Yeah?
and count the rest.
That's right, yeah. Do you
Of
get
the
it? Do you get this?
Yes.
Yeah, that's what we start the border doing the depth first search for the pixel for the island. Right? Yeah? And after that, look, all the islands that are connected to the border, all the islands connected to the border are marked as zeros. And what's next? The second step we already know. Yeah, we start from, then we go through each pixel, and if it's an island, we do the depth first search and increment the counter. Easy. Okay, let's do this.
Did you just prove something, Daddy?
Yeah.
Was that you?
Yeah, okay,
You
I'm going to
write
write it
it.
here because it's a bit long. Okay, so depth first PEF count island, count surround the island. Yes, surround the
I'm
island.
not letting it. Oh, I'm trying to
Let's
not
do
let
this metric, okay? If not metric, if this given is empty, if it's empty, we return how many? Come on, let's
0.
yeah, because there's nothing here. And then first of all, I need to get the rows and columns. Yeah, rows, columns equals length m.
Why are you writing so small?
Yeah, length m and length.
Look at
Okay, that's fine. That's m what? M what? What?
Because he says it there's a lot.
The rows is length m, and how about columns? Length m what? Come on, what should I put it? The number I put here. What's that? 0. Well done. Come on, this we've been.
And
Can you not touch my things, please? Okay.
He has so many money.
bed.
Yeah. Okay. So now, what should we do now?
Wallet.
What should we do now? We should define a depth first search function. Yeah? Let's do it. Define.
Vacuum.
Define depth first search.
Vacuum.
And then we have what? We have these rows and columns,
Bed.
right? Yeah. Eric?
Bed.
Okay. Look at me. So how can we check if
Seat.
this R and C is within the border? Okay. So what's the R? What's the very range of R?
My
Eric?
new seat.
What's the very range of C? The rows. What's the very range of R? Belongs to what? Start from 0 to what?
To the
R. The rows. Rows. Yeah.
Rose.
Rows. Look.
seat.
Look at this. R belongs to.
The
This is
seat.
belongs to.
Wait, what? That looks like really.
Yeah. Look.
can you write
What's the
that?
difference between this and this? What does it mean? This is R belongs to 0 to, that's the range. Lower bound, upper bound, but I use the square bracket and then this parentheses here. Can you guess what's the difference? Can you sit down? Why are you so busy, Ryan?
It's about the mutable.
No. Mutable is in there. This is inclusive. This is exclusive. It means that you can have R equals to 0, but you can't have R equals to rows. So what's the maximum value of R? What's the maximum of R if you count with rows?
0.
No, the maximum. The maximum R is what? I just say it can't be rows. So what's the maximum?
Columns.
No. This here, come on. 0 to R rows what? It can't be rows. So what's the biggest number that can't be rows? Rows what?
Rose to infinity.
Rows 1. Come on, it's not a hard question.
Rose minus 1.
Come on, how hard will it be? Yeah. Okay, and then these columns. What's the range? It's the same. 0 to columns. So what's the maximum of C?
Columns.
Columns what? It can't be equal to columns. So
Plus. Column plus. Column minus 1.
minus 1. Okay, that's it.
Yay!
Look, so if it's out of range, look. If R is smaller than 0, or C is smaller than 0, or R equal rows, or bigger equal rows, or C bigger or equal columns, what should we do? We just return it because it's out of range. Right? We're doing the depth first search. So now I just need to make this pixel at RC equals to length to 0, right? So M RC equals 0, right? Okay, so now at this point, so what should we do? We need to do the depth first search in 4 direction, right? Okay, so can you tell me? Depth first search R plus 1 C. Depth first search RC plus 1. Can you tell me what's next? Depth first search what? No, R plus 1C, RC plus 1, and then what else? R minus 1C, right? And therefore such.
Wait, what do you mean? Oh yeah, I was about to say what's DRS.
What? RC minus 1, yeah? Is it enough? Right. Look, at this point is RC, yeah? I'm here at this point. I'm at this point. So what's R plus 1C? R plus 1C is here, right? And look at this here. RC plus 1. RC plus 1 is here. R minus 1C is here.
Ow.
RC minus 1.
Ow.
Here, right? So it's 4 direction, yeah? Yeah, you can do this in 4 direction. I just do this in 4 direction. But we look at you can do a loop, yeah? You can just do this. 4
Just rub it
dx
out.
dy in what?
What's DX? What's DY?
Dx, yeah, good point. It's just the 2 variables to define the
I think
offset.
I made that up.
Yeah. Define the 2. Look, tuple, yeah? 0 minus 1. Minus 1, 0. 0, 1. And then 1, 0, yeah? In 4 direction. And then do what? DFS. R plus dx, look. And then C plus dy. You see? So you can transfer this to this. Because look at this. This is a tuple with 4 vectors. Yeah? The offset of rows, the offset of columns, right? Can you look at me? Yes?
Yeah.
Okay. If I do this, and then this is the depth of search, okay? I'm going to write this here a little bit. Or R smaller than 0, or C smaller than 0, or C bigger than equal rows, or R bigger or equal than rows. That defines it.
That's just like a tongue twister.
Yeah, okay.
R,
Look at it.
R
When is this is when? What does this mean? Out of range, yeah? Out of range.
C.
The coordinate, the R and C is out of the board. And then I mark it as visited. I mark it as the 0. Mark it as water, okay? Right? I want to depth search, I want to mark it water. And then this what? Going to 4 directions, yeah? Going to 4 directions. Okay? Okay, so this is depth search. And now I just need to travel the border. How do you travel the border? If this, look, this is the metric. And I told you that how do you travel? How do you visit this? How do you get the pixels in the border? How do you get?
Wait, I think I don't know.
Come on. Why do you mean to know? I can go through each pixel and check if it's on the border, right?
Yeah.
How do you check if it's in the border? I can do this for R in
It's a 1.
range. No. Range rows, yeah? And for C in range columns, yeah? Okay, if what? If R equals 0, yeah? If this one is R equals 0, right? Look at that thing. This is R equals 0, right? Or, what's this? What's this row? What's this? This is R equals 0. And what's this?
R equals.
Rows minus 1, yeah?
No.
And what's this?
No, yeah,
What's
no,
this?
yeah, no.
Columns.
C equal what? C equal what?
0.
Or what's this?
C.
Equal what?
Column minus 1.
Well done, right? And then once this is in the corner, then I do this depth search. RC, right? Huh? So in the border, if in the border I do the depth search, but it's better you put it here. If M RC, right? If it's the length, you do the depth search, right? If it's not a length, I don't do the depth search, right? If this is 1, I do the depth search, right? What's the time complexity in this one? If there's a 2 loop here. Oh, what's the time complexity? There are 2 loops.
N square.
N square, or you are rows times columns. Okay, it's better to be exact. Yeah, rows times columns. Can we do better in just this bit? Can we do better? Yeah. Can we do better? Do we need to visit any of these in the middle? Do we need to go through anything in the middle?
No.
Because it's not border. Good job, it's not border. So we can just skip it, right? We can turn this into 2 for loop. So for R in range rows, right? Look, range rows.
All of put islands in the middle are
So
surrounded in
look, R is from 0 to rows. So what should I do? I should just do this step first search. Row. What's the column of this one?
our column equals 0.
0. Yeah, look, R is from the rows column. And I also need to do this, right? What's the column of that one?
Which one?
Yeah. Look, because I iterate the R.
Minus 1.
Column minus 1, yeah. You see? Okay, so and now I need to iterate these two, right? So look, for C in range columns, yeah? D, F, S. So what's this one? What's the row of this one? What's the row number of this one? What's the row number of the first one?
It is row equals 0.
0 and 0C, yeah? And D, F, S what? What's the rows of this one?
R minus 1.
Rows minus 1C. You see? These turn into these two 4. So what's the time complexity of this one? If I don't consider the content of that. So what's the time complexity of these two, this agrand and this agrand? Yeah, ignoring the depth of search, okay? What's the time complexity? This is ORC and what's this? This is R and this is C. So what should I put in the middle? There are two for loops, separate, independent.
Plus.
Yeah, we're done. You see, you do this and do this, so it's part together. But this one is what? You do this. For each one of these, you do this. So it's multiplied. Yeah? Makes sense. Which one is better?
R plus C.
Of course, R plus C. Okay. Good job. Okay, so yeah, we're going back to this. And therefore search it, and we mark all the length connected to the border into 0. And then what should we do next? We just have to go through. We just have to go through what? Go through the middle, yeah? Therefore search. Go through the middle. For R in range. What? Go through the middle. Do we need to go through the board again? Do we need to go through the board again? No, right? So what should I put here?
Rows.
Rows. If you put the rows, what happens? It's the same. You will start from 0 to rows minus 1, right? Do we need to consider the 0 and rows minus 1?
No.
So what should I put? What should I do this here? Range what? Sorry?
1.
Yeah, and then what's the second parameter?
R
Rows minus
2.
minus 1, because at the beginning, remember, range 10 up to 10, not including 10, right?
Yeah.
So I need to minus 1 only, right? Because this is, yeah, this means what? If I range what? 2, 10, this is the same as 2, 10. Yeah, you see? Square bracket, inclusive. Parentheses, what? Exclusive. Yeah? Do you know inclusive and exclusive? What does this mean? What does this do? What's the difference between?
I think one of them is that it includes the number you've been given.
One
Yeah.
of them is above the 6 on the...
No, inclusive means that contains it. Exclusive that does not contain it. Okay? So 210 means that 210. How many numbers between these? Given a range, if it's integer, how many integers are in this range? Can you list the numbers?
Wait, inclusive or X?
Yeah, inclusive. Here, I just said.
Oh, okay, so
What numbers are between this range? The integer.
3. Oh no, 2.
2.
3, 4, 5, 6, 7, 8, 9, 10.
10?
Oh no.
Inclusive, that's what I'm saying. Yeah, this is the number, okay? Got it?
I was like,
It's easy, yeah. Okay, so for R and another, we want to put the answer here, yeah? Answer equals 0. For the length, yeah, the length not connecting to the border, yeah? For C in range, what should I put? Columns,
columns, yeah.
and then what? Columns what?
-1.
Yeah, columns minus 1 is the same. Look, if it's the length, what do we do? If it's the length, what do we do? Alright, if it's the length, we do the what? We call the depth of search, right?
Yeah.
And then we need to
Depth of
increment what?
please.
Increment what?
You need to increment.
The what? Which one? Come on, it's there. Come on.
What?
Look, if it's here,
1.
yeah, if it's answer plus what?
1.
Yeah, answer plus 1. Okay, and then just need to return.
Answer!
What's the time complexity
That
for
takes
this
a
one?
long time, dude.
What's the time complexity? Don't call me dude. Come on, guys. Huh?
But you are, dude.
What's the time complexity?
It is
Yeah?
spinning top.
O-N.
ORC thingy.
Yeah, ORC. Why is it OR times C?
Well,
I'm using rows and columns.
OR times C. Why? Can you tell me why?
Well,
Why? Can you tell me? Because each pixel is visited exactly how many times?
I'll say.
Come on, no, there are R times C pixels, and I'm
Yeah.
saying each pixel is
One.
visited constant time, so that's ORC. Yeah, yeah, got it? Okay, so can you tell me how do we do this? Just you don't need to write the code. Just tell me what do you learn today? If you want to find the what? If you want to find the number of surrounded island, which is only this one, right?
Yeah.
So how do we compute? How do we count the number of surrounded
Just
island?
go around it. Boom, 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 boom. And
So-
you see this, and you're gonna like, okay, I'm gonna break this island.
Look,
Turn
what?
it water.
We first of all start doing the depth of search and mark the length as 0 by following the border, right?
Yeah, just this.
Okay, and then look after this. Look, what happens if I do the depth of search? Which two pixels will become 0?
These.
These two, okay. And then I start in the middle
They
one,
look
yeah.
like eyes.
Yeah. I start from the middle one, yeah. I only start here pixel by pixel, and if it's 1, I do the depth of search and mark the connected pieces to 0, and then I do the increment the answer, right? And return the answer. Okay? The time complexity ORC because each pixel is visited a constant of time. Okay, that's it for today. Good job. Bye bye.